Now we're going to do some simple epsilon delta proofs. So the very first one, or the very easiest thing to do, is to use a line, right? So I picked a line, y equals 3x plus 2, and I picked some random point, x equals 1, because I like whole numbers. And we're going to prove that the limit as x goes to 1 of this line is actually 5. So when I say we're going to prove it, we're going to use the definition. How do we use the definition? Well, let's write it down first. We're going to try to show that for all epsilon greater than 0, there is a delta greater than 0, so that and I'm just going to write the general definition first, and then I'm going to write down specifically what we're going to show for this particular limit. But the general definition is when x minus a is less than delta, greater than 0, then f of x minus L is less than epsilon. So that is the general definition. But in our case, a is 1, f of x is the line, 3x plus 2, and L is the point that we're going for. Okay, so that would be writing like this: x minus 1 is less than delta, then f of x was 3x plus 2 minus 5 is less than epsilon. So this is what we want to show. And really what we want to show is the relationship between these two delta and epsilons that will make it possible. So like delta equals epsilon squared, whatever. There's a bunch of, whatever it ends up being. And so let's do it and see what it ends up being. So the way we're going to go about this is first we're going to kind of like scratch it out a little bit, okay? We're going to assume we're in some delta neighborhood and figure out what epsilon neighborhood that gives us. And then we're going to kind of turn it around a little bit and write it out nice. So let's assume for the moment this guy. So we're within delta of the point 1. We don't know what delta is here. It's okay. Now let's look at what this side is that we're supposed to show. I'm going to write it down here. 3x plus 2 minus 5. All right, well, we can do something with that, right? This is just 3x minus 3. Absolute value. Absolute value is always, right? Because we need it from both sides. Well, it looks like I take a 3 out there. And there's 3 times x minus 1. Magic, right? Because look, here's x minus 1. Here's x minus 1. X minus 1, we assumed it was less than delta. So 3 times x minus 1, absolute value of x minus 1, obviously, is less than 3 delta. Okay? Now what I need is for this whole guy here to be less than epsilon. So let me just make that equal epsilon. Right? Oh, my shower's in the way there. So we have 3 delta equal epsilon. What does that tell me? Or if I have delta being epsilon over 3, then that's actually the ratio I want. That's the relationship between epsilon and delta. So along my entire line, whatever I want my epsilon to be, I just, take delta to be epsilon over 3. That's what it's to say. Okay, so, and this is essentially my proof, but it would be really nice to write it out in a very nice way. In other words, like more or less what's written up here. So I can kind of rewrite this, or I can just say that, right? So I can say, given epsilon greater than 0, we let delta equal epsilon over 3. Then, when my x minus 1 is between 0 and delta, my f of x minus L, right, which I can even write it like that if I want. L was 5, right, which is 3x plus 2 minus 5. So we can see from up here, this is just 3 times x minus 1. This is 3 delta, or well, less than 3 delta, right? Because x minus 1 is less than delta. And then this is 3 times epsilon over 3, or epsilon. So I have shown that this thing works. Okay. So that's kind of the thing. The whole deal is for any of these proofs, if you are ever in a position where you want to do one, is to find that relationship between delta and epsilon. Let me see if I can do something about this. Let's see if that might make, still, that's a little bit better. Okay, it'll do for now. Okay, so that's one example. That's the easiest example, right? Yay. So let me do one that's a little bit more complicated, but not too bad. And then we'll just leave it there because you'll never have to do this in calculus, 1, 2, 3, but if you get up higher, then you will have to do this. But I don't really need to make it super, super complicated. If you care, you can look them up. All right, so I did a line, so let's do a parabola, right? My favorite. X goes to 2, right? If I'm taking x squared, then of course it's going to be 4, right? So we know that that's the limit. So I only have to prove that what we know is correct by using the definition. We're going to put those in there. So what is this? What am I going to prove? I'm going to assume, or I'm going to start out with the x minus 2 being less than delta, and then I'm going to show that x squared minus 4 is less than epsilon. And I'm going to use that to figure out what that relationship has to be between the delta and the epsilon. Okay, so again, we're going to start out with that idea that we're on some delta neighborhood, and we just have to figure out how the delta is related to the epsilon. So if I start out with this x squared minus 4, you can see immediately, and you know already, oh, I have to somehow get this x minus 2 in there. So I just factor. This is x plus 2 times x minus 2. And absolute value of a product is the product of the absolute values. So this just becomes x plus 2 times x minus 2. And then since x minus 2 is less than delta, we get this is x plus 2 is sitting here, and then I just get an extra delta. Okay, fine. Oh, see, but it's a little bit different, though, than the previous example, because I just had a 3, and I was fine, right? This is not just fine the way it is, because it has an x in it. And we want that relationship between delta and epsilon not to have an x in it, because it has to be true for all x in the interval, right? All x that is delta close to our point A, which in this case is true. So in this case, we have to do some more work to get rid of that x. We have to essentially estimate this. It doesn't have to be exact. And that's the interesting thing about these proofs, is that it's a less than sign. So I can make this bigger if I wanted to. And in fact, you saw that if you watch the little thing, like if we made the delta bigger, it was okay, as long as we didn't make it too small. But because you have this x here, you have to have at least some knowledge of how big you can make it so that the whole thing is going to work. So here's a little trick that you can use in this case, right? If I basically figure out what's going on here, I'm going to draw it real quick. Let's say this is 2. And this is my delta neighborhood, right? So I'm delta back and forth in the x. So the thing is, I really want delta to be not like 10, right? Because I know that what I'm really interested in, so here's my epsilon, is going to be like my epsilon, and that would be like my delta box. I know I want epsilon to go pretty small, so I'm really kind of only interested in sizes that are pretty small. So it doesn't have to be super small, but I mean 100 is a little bit silly, right? Because we want it to go small. So what I'm going to do is I'm going to take a maximum possible delta, which will let me bound that, right? It'll let me estimate that. So let's let delta be something, the biggest delta to be something, you know, easy, like 1, right? Why not 1, right? So take delta less than or equal to 1. Okay. Now, what does that mean for me here? Let's look at it. That means if this delta is 1, then this is 1 and 3, right? Okay, so let's write that down because we don't need the picture for that. If x minus 2 is less than delta, which is less than or equal to 1, we have absolute value of x minus 2 less than 1. Okay, so that's minus 1 is less than x minus 2 is less than 1, or x is between 1 and 3, like we saw from the picture, but it's just like, let's look at the math too. So now we want to go and see what this tells us about this, right? Okay, so absolute value of x minus 2, right? Plus 2, right? If x is between 1 and 3, what's the biggest possible thing that's going to happen here, right? The smallest thing it could be would be 3, and the biggest thing it could be would be 5, right? Okay, and I don't even need the absolute values at this point because it's all going to be positive. So I can just go ahead and right? X plus 2 is going to be between 3 and 5. And luckily, everything's positive because this is a super easy example. I don't do anything fancy, right? Obviously, absolute value of x plus 2 is also going to be between 3 and 5. So I have this. I want to make sure that everything is still less than, so I want to pick this upper bound. So then I can put that in there, less than 5 delta, right? And now I do the same thing I did in the previous example, that equal epsilon. Okay, and that gives me that delta is epsilon over 5. But I have to be a little bit careful, right? Because I also had this. So now I actually have two statements about delta, right? And they both have to be true. But it's easy, I just take the smaller one, remember? Because from the picture it was like, well, if delta's smaller, you know, it's okay, right? So I just take the smaller one. Let me erase, I'm not sure what I'm going to erase here. I'm just going to erase this part. So I put these two boxes together. I'm going to say given epsilon pick delta to be the minimum of 1 and epsilon over 5. Okay? Then all this stuff that I have up here is going to be true. So I can rewrite that, or I can just sort of rewrite it quickly. F of x minus 4, which is x squared minus 4. Which is less than x plus 2 times delta, which is less than 5 delta, right? Equals 5 times epsilon over 5, which is epsilon, right? So at some point, And what we're really interested in, and that's another point, is we want to get epsilon very small. So at some point, obviously, if epsilon is smaller than 5, right, then delta will be smaller than 1. So I don't really have to worry about the delta equals 1 case when I write this down, because I'm really interested in small values of epsilon. As epsilon is going to 0, I need to see that delta is going to 0 too. So eventually my delta is going to be less than 1, and I don't even think about that 1 anymore. I just want to make sure that it's in there so that I can see why that I used it to get my bound. That's all.